Hi there, this is the RPS Project. I'm Richard, and today I'm going to have a quick look at the LM380 audio amplifier. It's a discrete IC package for audio amplification. It's a very simple device. I could have got a data sheet off for it. I did have one hanging around somewhere. Put it about anywhere. But I'm just going to do the basic circuit because I just want to see what it does, just to see if it comes on and gives me something out from a basic input. So I suppose I better get and have a look at it. I've got it drawn up on the whiteboard, so we'll have a look at that first. Basic layout for the circuit I'm going to be doing, and then we'll move on. So here it is on the whiteboard. Very basic design. Now I've got the LM380N. This is the 8-pin version. It quite often you'll see this in a 16-pin version, and the middle pins, like the 3 middle ones, like 3, 4 and 5, 9, 10, 11, something like that, they're all part of the heatsink. So it makes you think, does this thing get a bit warm when you got it under quite a load? Don't know, but I've always gone for the 8-pin. I prefer the 8-pin. Smaller package, I suppose it's less things to deal with, and well, there you go, basic, very simple. Now pin 1, there's no connection, and if you can see this pointer stick, I need a bigger pointer stick really, don't I? That's better. No connection, pin 1. Pin 2 is plus in or non-inverting input. Number 3 is the inverting input. 4 and 5 are ground. Output is pin 6. Pin 7 is the voltage supply, and then you've got pin 8, bypass. Who knows, eh? Bypass. Just put a capacitor down to ground, that's all I've done. Now I haven't really put any values on here of components. If you look at the data sheets, I'm sure it'll have examples with values for the components, but I'm just winging it with whatever I've got and seeing how it comes out. Here we're talking sort of anything from like 10 ohms up to 100 ohms max, probably not even 100 ohms, but if you've got like a 10 ohm resistor in there, this being, I don't know, something small, I'm going to shove in probably 100 nanofarad, something like that. The bypass capacitor, again you're talking what, 47 nanofarad, 100 nanofarad, something in that sort of range. Over here on the input, now it's showing a pot here and a resistor. I'm not sure if I do it that way or maybe change it, but I definitely want the capacitor on the input, something quite high really. 1 microfarad I might try and find if I got me 1 microfarad. Yeah, I'm sure I've got 1 microfarad capacitor in there. Pin 1 no connection, pin 6 output, and then a whopping great electrolytic on the output, something like in the order of 470 microfarad, maybe 1000 microfarad, and then out to the speaker. Very, very simple. Don't want it anything technical. I just want to see if I can make this circuit work and see if it gets me something out of it. I suppose the thing with this type of circuit is that you can experiment with changing the different values of these resistors and capacitors on this output stage to help with filtering, I suppose, filtering for noise. If you want to keep the noise out of it, you could put a capacitor on the input, like over here, just to help with noise on the power line. Change the pot value and just change stuff and just see what it does, see how it affects it. So I'm just going to set it up as a basic circuit with whatever components I've got, and then we'll see if it works. So here we have it on the breadboard. It's a bit spaghetti junction again, sorry about that. It's a bit of a nightmare. LM380 in the middle there. Pot at the front end, lots of bypass capacitors, capacitor input, Yeah, believe me, I have set it up as I showed on the circuit, but just a bit messy really, I suppose, more than anything. Well, there you go. Well, turn it on in a moment. I've got it connected onto my little load, 8 ohm, well, 8 point something or other load, isn't it? I mean, this is my little load I made, and if we come up, let's see if I can get it in shot. I've got my function generator, which I have set to go the other way, 1 kilohertz, 100 millivolts, which is fine, reasonable, should do just what I want it to. And then what I'm going to do, I'm going to pan up onto the SIG gen. I think we got that in shot. So yeah, turn it on, I suppose. Let's get the function generator on. There we go, it's on 100 millivolts, 20 millivolts per division. So what we got there, it should be 20, 40, 60, 80. Yeah, it looks like it's been attenuated to some extent on the input. It should be 100 millivolts. Never mind, not to worry. Turn it back down. But yeah, that's about there, I suppose. Anyway, let's turn it on. 12 volt supply on this one. Not really, you know, this is set to 1 volt per division. Let me just change this. Wrong way. Now that's 100 millivolts per division. And as you can see, I'm already getting an output, but it is shifted. There's a phase shift there. Even though I've got a pot supposedly dragging the signal straight down to earth, some signals getting through there. So I suppose I better turn it up. Now, excuse the noise, because you're going to see a lot of noise, because my finger's going to go on the pot to hold it. Yeah. Oh, it's nasty, isn't it? I'm working as a really nice aerial today. Oh dear, get my finger off there. Ooh, yeah, it's almost like this goes. Let me just see if I can 500 millivolts per division. So there's a little bit of signal already coming through. Now I want to turn this up. Let me see if I can find another screwdriver that doesn't make me act more like a like an aerial, because there is a significant amount of noise coming through. I wonder if that one will do it. That's a bit better, a bit less noisy. But I've noticed as soon as I start to turn the pot, I'm getting a signal, and the signal rises really, really quickly. I don't know if I can do this without. Yeah, I've got a lot of noise in here, and then it doesn't go any further. So perhaps I need a smaller pot. Something, you know, I've got a 10k pot here. Perhaps I need something like a 1k pot or something. Would work better. And then it sort of suddenly collapses and disappears. Yeah, very noisy. I think that's just because of what I've got set up on the breadboard. It's, you know, really a bit rough and ready. But yeah, it does work. I'm giving a signal. Not much control over it though, even though I am getting quite an output. 500 milliamps. So, you know, you're talking 2 volts peak to peak from 100 millivolts. So yeah, that works. That actually does, I suppose, what it's meant to. So I mean, let's have a quick look at that. That's what we've got. 1000 microfarad, no, 470, yeah, 1000 microfarad out here. I've got a 15 ohm resistor there and a 100 nanofarad. That's a 10 microfarad electrolytic, and then I've just got this with like 100 ohms here and this 10k pot. So I suppose I'd have to play around with this to get a better control on the input, and maybe change and mess about with this over here, see if it works a bit better. But as a general rule, yeah, that actually works. So that's a working circuit, just not very refined. So there you go, a great little device, the LM380 380N 8-pin dip package. It sort of does what it should do. Takes a signal, amplifies it quite a bit. I'm sure that if I was to put this on a proper circuit board, you know, like a strip board or some other soldered on device, then get all the components together, get rid of spaghetti junction, I'm sure the thing would work a lot better and give me much better output. It needs refining basically. It's in its really rough and ready state. Tweaks here and there to spy what capacitors I want, what resistance I'm going to need, what it's going to give me on the output. Connect a speaker up to it and see what sort of audio signal sound quality I get out of it. And it also depends on the speaker, but I mean, I suppose you could use this for small devices, for like small speakers, maybe even some headphones, I don't know. But yeah, nice little device. Just needs a bit of work. Refining, that's the word, needs refining. But there you go, that's a neat little device, LM380. Anyway, if you didn't like this video, you know what to do. If you did, give me a thumbs up, subscribe, and all comments are welcome. See you next time.